The weird part is not that an AI can answer questions. The weird part is when it asks to open your calendar, read a database, or create a file. Like software suddenly grew hands. For years, every app connected to AI in its own messy way. One tool had a custom plugin, another had a private API wrapper, another needed a special integration. It was like every charger in your house had a different shape. That is why people compare MCP to USB-C for AI. USB-C does not make your phone smarter. It gives many devices a shared connection shape. MCP tries to do something similar for AI apps, tools, and data. MCP is getting attention because AI is moving from chat to action. Viewers are asking why agents can suddenly use GitHub, search files, query databases, or operate business tools. The answer is not magic. It is a connection standard. MCP is not a new brain. It is not a model like GPT or Claude. It is not a guarantee that an agent will make good choices. Think of it as the rules for how an AI application talks to outside systems. There are three main pieces to understand. A host is the AI application you use. A client is the part inside that app that manages a connection. A server is the tool provider that exposes useful abilities or information. The host is where the human experience happens. It could be a desktop assistant, a coding app, an agent builder, or another AI product. The host shows the chat, manages permissions, and decides how much control the user gets. The client is like the adapter hidden inside the host. You usually do not talk to it directly. It opens the MCP connection, asks what the server can do, and passes messages back and forth in the agreed format. The server is where the useful outside capability lives. A file server may expose file search. A database server may expose safe queries. A project management server may expose tasks, tickets, or comments. The server describes what it offers. When the AI app connects to an MCP server, it does not instantly know everything. First, the client asks for the server's capabilities. The server replies with a menu of tools, resources, and sometimes prompt templates. A good way to picture MCP is a restaurant menu. The AI does not walk into the kitchen and do whatever it wants. It sees a menu of allowed actions, chooses one, fills in the required details, and waits for the result. If this kind of simple breakdown helps you understand fast-moving AI tools without the hype, consider subscribing. We will keep separating the useful mechanisms from the buzzwords as this space changes. The most famous MCP feature is tools. A tool is an action the model can request. It might search documents, send a message, create a pull request, fetch a customer record, or run a calculation. Tools are how chat becomes work. Resources are different. They are pieces of information the server can expose to the AI application. A resource might be a file, a database schema, a design document, or a log. Resources help the model understand the environment before acting. Prompts in MCP are reusable instructions or workflows provided by the server. For example, a documentation server might offer a prompt for summarizing release notes. A code server might offer a prompt for reviewing a pull request. Imagine you ask an AI coding assistant to explain a bug. Without MCP, it may only see the text you paste. With a connected code server, it can request the relevant files, inspect symbols, and use a search tool inside the project. Here is the flow. You ask a question. The model decides it needs outside help. The host shows available tools from connected MCP servers. The model requests a tool call. The server runs the action and sends back a structured result. This matters because the model is not supposed to randomly control your computer. It asks through a defined pathway. The host and client can add approval steps, limit access, and show the user what is about to happen. Standards matter because they reduce repeated work. Before a shared protocol, every AI product needed separate, custom integrations for every tool. With a standard, a toolmaker can build one MCP server, and many AI clients can connect to it. For developers, MCP can turn integrations into reusable parts. If you build a server for your company's knowledge base, you do not want to rebuild the same connection for every assistant. You want one careful interface that many hosts can use. For users, the benefit is portability. In the best case, your favorite AI assistant can connect to the same approved tools as another assistant. You are less trapped inside one vendor's private plugin system. For agents, MCP gives a cleaner way to discover abilities. An agent needs to know what actions exist, what inputs they require, and what comes back. A standard menu makes that easier than reading a random website or guessing an API. One common misunderstanding is that MCP replaces APIs. It usually does not. Many MCP servers still call normal APIs behind the scenes. MCP is more like the agent-friendly front desk that wraps those APIs in a way AI applications can use. MCP servers can run locally on your machine or remotely on the internet, depending on the product and configuration. A local server may help with files or developer tools. A remote server may connect to cloud services or company systems. The important question is not just what the server can do, it is who gave permission, what scope was granted, and whether the user can inspect the action. A calendar tool that can read events is very different from one that can delete them. The USB-C analogy has a dark side. A universal port is useful, but it can also connect to dangerous devices. MCP makes tool access easier, so security has to be designed carefully. A bad server or bad tool description can create real risk. One risk is prompt injection. A document, web page, or tool result may contain instructions that try to manipulate the AI. If the model treats untrusted text like trusted commands, it might use tools in ways the user never intended. Another risk is a misleading tool. A server could describe an action as harmless while doing something more sensitive. This is why tool descriptions, server trust, approvals, and auditing matter. The model should not be the only line of defense. Another beginner trap is assuming every MCP feature works everywhere. In practice, different clients may support different parts of the protocol, and product behavior can vary. A server that works beautifully in one host may feel limited in another. There is also a practical problem called tool overload. If an agent connects to too many servers, it may receive a huge menu of possible tools. More choices can make the system slower, more expensive, or more likely to pick the wrong action. A good MCP server is often boring in the best way. It exposes a small number of clear tools. It names them honestly. It validates inputs. It limits damage. It returns structured results that the AI can interpret without guessing. Imagine a support agent connected to a ticketing system. The MCP server might expose tools to search tickets, read a customer profile, draft a reply, and update a status. The host might require approval before anything is sent to the customer. Now, imagine a personal assistant connected to Notes and Calendar. It could find last week's meeting notes, compare them with tomorrow's agenda, and suggest follow-up tasks. The useful part is not the chat. It is the controlled bridge to your real information. What is known is that MCP gives AI applications a shared pattern for connecting to tools and context, and major AI companies have supported open work around it. What is still speculation is whether MCP becomes the permanent universal standard for agents. The bigger shift is that AI products are becoming less like isolated chat windows and more like operating layers over software. MCP is one attempt to make that layer less chaotic. It gives agents a common way to ask for help from the outside world. So MCP is like USB-C for AI in one specific sense. It standardizes the connection. The host is the app, the client manages the link, and the server provides tools, resources, and prompts. It does not remove the need for trust, permissions, or good design. If one part of MCP still feels confusing, ask about it in the comments. You can also suggest the next explainer, like AI agents, prompt injection, tool calling, or how coding assistants actually use your files.